Good afternoon, students. How are you?
Good afternoon, sir.
Mhm.
I'm good. How are you, sir?
Making the best of it, dearest. Making the best of it. Making the very best of it. All right. I think we should hit the ball, the ground running, and and just for me to confirm with you. I keep forgetting where I'm at. We did these questions last class, right?
Yes, sir.
Okay, 4 times. And did I give you any for homework?
No, sir.
So we would have covered all of those. All right, so I'm on the final piece. Um, I'm thinking that I can give you a question of this nature because it does include what it is that we have been doing. So I want you to just run through this question. So the question includes, it's of an exponential form, and it says 2 to the 2x plus 3 times 2 to the x minus 4 equals 0. So if they give you a question of this form, the truth of the matter is I really don't know what form they're going to give the question, and I don't want to not give it to you. Put it this way. It's better we go through these and they don't give it to you than we don't do it and you see a question turn up on a paper and you don't know how to do it. So let us go through the question. The truth is, we would have been using quite a number of these laws, and we know how to solve factorization, and we know how to solve those other exponential equations, with simple powers. So the rest of the question we know to do. The only thing that is going to be new is this format. So I'm saying, let us do a few of these questions. I may not do all the questions that I have laid out here. I think I may have 8, 10, 12, 14. I may not do all of those questions. I may just go through one and give you maybe 3, 4, no more than 5 of them to do. And I'll leave the rest on paper for you to do in your practice time. All right, so let us go. And this completes my unit, or those are the solution. This completes the unit on logarithms and exponents. And we should be ready to begin our next unit. All right, so the question says 2 to the 2x plus 3 times 2 to the x minus 4 is equal to 0. So we will immediately recognize that 2 to the 2x and 3 times 2 to the x cannot be combined to give a single expression. There is no way I can combine these two in a single expression. Why, sir? Aren't the bases the same? The base is the same here, 2, and the base is the same here. But this is a number that is being multiplied by the 2. And between the signs, you don't have a multiplication sign or a division sign. You have an addition sign. Remember the laws that we did centered around multiplication and division. None of the laws that we did centered around addition and even by extension, subtraction. So I can't apply any of the laws. So we have to use a substitution. So what do you mean multiplication and division? When I'm multiplying and the bases are the same, I add my powers. When I'm dividing and the bases are the same, I subtract my powers. And the sequence is the numerator power minus the denominator power. I did not give you a law that speak to bases being the same and you're adding. It's only when you're multiplying and when you're dividing. So there is really no law to this. So in order for us to get that question out of the way, we will have to go and do some substitution. So look at how I'm going to be substituting now. We're going to make a substitution for 2 to the x, and this will result in an equation in y. And the simple rule is you're going to be looking for the smaller of the two. You're looking for the smaller of the two indices. You're looking for the smaller of the two indices. So what do you mean by smaller of the two indices? I have those two contending with. I have those two contending with. All right? Now, do you agree with me that 2 to the x is smaller than 2 to the 2x?
Yes, sir.
All right. So, so we're looking at the smaller of the two terms. The smaller of the two terms. The smaller of the two terms. All right? Now, I'm going to make a substitution for the smaller of the two terms. And I'm going to say, let y be equal to. Sometimes in the exam, they will say substitute for u equals. Substitute for u equals. So those of you who are doing Cape 2, this topic is going to come back into Cape 2. So it would be nice if you understand this, so that when Mr. Rokun is going through Cape 2, you are already there. All right? So the simple rule is to look for the small of the two indices and make it y. So I recognize that this is smaller. So therefore, we're going to let y be equals to 2 raised to the x. Y equals 2 raised to the x. Y, sir? It could be anything you want. It could be u, it could be p, it could be any variable other than x. Since your equation is in x, it could be any variable other than x. All right? And then we're going to have, I'm making a substitution. So when we square y equals 2 to the x, this is what is going to happen. Y squared, the squaring all of this is going to be equal to 2 to the x squares. We're squaring them. We're squaring both sides. We're squaring both sides. We're squaring both sides. All right, so we're squaring y and we're squaring 2 raised to the x power. So when we square y, we're going to get y squared. And when we square 2 to the x, recall a to the m raised to the nth power is equal to a to the mn. A to the m raised to the nth power is equal to a to the mn. So when we square 2 to the x, we're going to end up with 2 to the 2x. When we square that, we're going to end up with 2 to the 2x. It was along. And when we square it, we're going to end up with 2 to the 2x. So my y squared is now going to be equal to 2 to the 2x. And my y is equal to 2 to the x. So now that I have a substitution for y squared and for y, anywhere in the equation I see 2 to the 2x, I'm going to put y squared. And anywhere in the equation I see 2 to the x from here, I'm going to put y. So having substituted a value of 2 to the 2x and 2 to the x into the equation, so the equation here, I recall it here, we're going to now have this to be y squared plus 3 times y minus 4. Then you now have a quadratic equation. So when I saw in a WhatsApp group about Lord Jesus, let it not be any factorization, I smiled to myself because Me did don't know that this was going in a class tonight. All right. So all of this here, everything up here is the only new thing that we're doing. Everything else down here, from here on to the end of the question, we know how to do. So we're factorizing. Y squared plus 3y minus 4. What is the coefficient of y squared? Look at the board and tell me the coefficient of y squared.
1.
1.
Very good. Remember, for the rest of you, remember, the coefficient of y squared is a number in front of y squared. The coefficient of y squared is a number in front of y squared. Coefficient of y squared is a number in front of y squared. And the number in front of y squared is 1. And then I'm going to multiply the coefficient of the y squared by the constant. So 1 times negative 4 is negative 4. 1 times negative 4 is negative 4. I need two numbers. When multiplied together will give me negative 4, but when added will give me the middle number, which is a positive 3. Which is a positive 3. So I'm going to be looking at positive 4 and negative 1 as my factors. I'm looking at positive 4 and negative 1 as my factors. Sir, why? Because I need two numbers. When multiplied together will give me a positive 4, a negative 4, I'm sorry. But when added will give me a positive 3. So the only set of numbers that we can multiply together to give us 4 will be 2 and 2 and 4 and 1. But when I add the two terms together, the middle number is supposed to be equals to positive 3. 2 and 2 won't work. Can you agree with that? 2 and 2 will never work because it's either I'm going to get 0 or I'm going to get negative 4. Can't work. So when we use our positive 4 and negative 1, when I multiply positive 4 to negative 1, I get negative 4. Check. That's what I want. When I add my positive 4 to a negative 1, I get a positive 3. Check. Those are the two conditions that are met. So negative 1 and positive 4 are the factors that I'm interested in. Everybody see the factors?
Yes, sir.
Yes, sir.
Good job. Those of you who are not seeing, it is important for you to find it. When I ask questions, say to me, sir, I'm not seeing it. If I hear yes, sir, I'm going to be moving on. Let's go. So now, when I have broken up my positive 4 and negative 1, I'm going to end up breaking up this positive 3y into positive 4y and negative y. So now I'm going to be able to group. When I'm grouping, I'm going to just drop two brackets with the first two terms, leave out the middle sign every time, and drop another pair of brackets for the last term. When I would have broken up the middle term into the two factors, then I'm going to write two terms in the parentheses, leave out the middle sign every single time, and then I write the other two terms in this other set of parentheses. So now, I'm saying what is common here that is common there. Quickly, answer.
Y.
Very good. And what will be left here? When I talk about y, what will be left?
Y.
Y and 4.
Y and 4 right here. What is common here that is common there?
Y and 4.
1. 1 is common between the two. So I'm going to have 1y and 4y. Hold on, sir. Why have this in pink, sir? I have this in pink because this sign here is a middle sign, and the middle sign here is a negative sign. Somebody will look at it and say, sir, up here you had a negative 4, but down here you have a positive 4. Why, sir? And here you have a positive 4y, and here you have a positive 4y. So why you have a negative 4 up here and a positive 4 down here? Simply because you have a factored out a negative sign. Terminal seed. All right, let's just check it first. Negative 1 times a positive 1y is a negative 1y. Agreed?
Yes, sir.
Yes, sir.
And this negative 1 times a positive 4 gives me what?
Negative 4.
Negative 4.
Teacher, so the negative 4 up top here. So just remember, Whenever you factor out a negative sign, always flip. Always flip the sign. Now, what is now common here that is common there? What is common here, guys? That is common here.
Sir, y plus 4.
Very good. So I can factor out my y plus 4. And when I factor out my y plus 4 from here, what is left on this side?
Y
Good. And what is left on this side?
negative 1.
See here? Y minus 1. So I'm now going to be saying either y plus 4 equals 0, the 1 here, or we can either say y minus 1 equals 0, the 1 here. And if y plus 4 equals 0, look at what I'm doing. I'm subtracting 4 from both sides. I don't want to hear anybody say, so we carry the positive 4 over the negative, or the equal sign to become negative 4. Teacher, sir, y equals negative 4. No, that's not what we do. What we do is we use the additive inverse. And the additive inverse of positive 4 is negative 4. So you're subtracting 4 from both sides. And then the 4 on this side will cancel out, leave a negative 4. The answer is not the same thing. Yes, it results in the same answer, but the methodology was incorrect. And the understanding is incorrect. Okay? And we do the same thing on this side, and we're going to get y equals 1. Now, the question almost finished here. One of the things that I will say to you is y equals 1. They never give us anything with y, you know. See word here? Let. We are letting y to be equal to something. So we are introducing a new variable. The original question never had anything with y. The original question did not have anything at all with y. Nothing. Nada. Zilch. Nothing. So we have to resubstitute. Oh, sir, that's the way point. No, that means you could use P or Q or R or S or T. That means I get the same answer because you resubstitute it out, right, sir? Thanks for asking. You are correct. So let's go. So I'm going to be resubstituting. I have y to be equal to negative 4. So recall that we are the ones to introduce y into the question. Therefore, we need to know to remove it. We need to remove it. Now we're going to make a substitution. So this 2 to the x is equal to 4. So we get 2 to the x equals 4 from. Watch me. See y here? Copy. Hold on a minute, please. Oh, Lord. So I'm recalling that y is equal to 2 to the x. I'm recalling that y is equal to 2 to the x. Now the value of y is 4, is negative 4, and the value of y is negative 1. Right? So I'm recalling that y is equal to 2 to the x, and that y is equal to negative 4, or y is equal to positive 1. Oh, so now, sir, I see it. So moving this negative 4 over to y. Very good. So I'm going to have negative 4 is equal to 2 to the x. Similarly, I'm moving this negative 1 over to the y. So I'm going to have 2 to the x equals 1. So I'm resubstituting. There are no real values for x that satisfy 2 to the x equals negative 4. Why, sir? we cannot take the logarithm of a negative number. We cannot take the logarithm of a negative number. We cannot take the logarithm of a negative number. We cannot take the logarithm of a negative number. The negative, the logarithm of a negative number is undefined. We cannot take the logarithm of a negative number. So, therefore, we're going to say no solution for that value of x. So this value of x has no solution. Then now we're going to be left with 2 to the x equals 1. Oh, sir. Yeah, man, we know how to do this, sir. Because we spent a lot of time on this last week. Absolutely. So 2 to the x equals 1, just to remind those of you who may or may not have been here, 2 to the x equals 1. We're using a law that says log to the base a of b to the n is equals to n log to the base a of b. So this now becomes it becomes x log 2 is equals to log 1. See here, converting this, so it will become x log 2 is equals to log 1. And I'm dividing both sides by log 2. So I'm going to have x is equals to log 1 over log 2. And when I evaluate this, I'm going to get x equals 0. So the value of x here is 0. All right? And I give an alternative one here. Value of x is equals to 0. Let's just check out now. Remember, we have only one solution. We have just one solution because the other solution is undefined. So I have just one solution. And we got that solution to be equal to 0. Now 2, come on now. So 2 times 0 is 0. All right? And 2 raised to the 0 equals?
1.
1. Anything raised to the power of 0 equals 1. So when you substitute 0 in this one moves to 1. But when we substitute 2 to the 0, we're going to get what again?
1.
And 1 times 3 is?
3.
And 3 plus 1 is?
4.
And 4 minus this 4 equals?
0.
0.
Right. You follow what I just did a while ago?
Yes, sir.
Yes, sir.
All right. Do me a favor. I believe you that you were very quiet because you were listening intently what sir was doing. What I'm going to do for you now is to give you, oh Lord. All right. I'm going to give you a few minutes. If you have to zoom in, zoom in. I'm doing it like that because I want to show you all the pages. Some of you may need to write, whatever it is, because I'm going to give you a question to do for me. I'm going to give you a couple minutes to walk through the question by yourself, and then I will come and take your questions. That's how we're going to be doing the mathematics. I go through it, give you a chance to look at it yourself, ask me your questions, and then we'll move on from there. So I'm giving you between 5 and 10 minutes. I'll check on you halfway. All right, start with me, please. I have only 17. There are quite a number of students absent tonight. Go ahead, please. Hey guys, where is it going?
Good,
Sir,
sir.
sir, can you explain why um why is 2x only y and not y squared?
All right, because you remember the law of indices says a to the m. Look right here at my recall. A to the m raised to the n power is a to the mn. So when you're squaring when you're squaring an index, it's not going to be 4x squared. It's not going to be 4x squared. It's not going to be 4x squared. You are going to be multiplying, remember, a number that is raised to a power, which in turn is raised to another power. You are multiplying both powers. So the reason this is 2 to the 2x is because of this law. And see, I pull out the law here. We did the laws. See, I pull out the law here to show you. So this is this. All right?
Okay, sir. I wasn't talking about the 2 to the 2x. I was talking about the 2x. Is it that because it's just 2x, that's why it's just y, and y2 is equal to 2 to the 2x?
You know, so me I talk to myself, I'm a mute. Jesus, Father, forgive me. I'm saying to you,
Sir, I was just going to ask you that,
what?
if you were talking, because I see you moving now.
Lord of mercy, I don't know what is happening to me. All right, yes, I was actually talking. So I'm saying to you, it's the same thing that we're saying. Um, I am letting y to be equal to 2 to the x. I'm letting y to be equal to this. And y is going to be equal to the smaller of the two. Yeah, we're letting y to be equal to smaller. See, just smaller of the two. So when you look at these two terms, you know that the one raised to the single power is going to be smaller than the one that is raised to the double power. So we are letting y to be equal to 2 to the x. Now when y is equal to 2 to the x, then when we square it, we're going to get this piece on here. Give me half a second. Team member calling. All right, are there any questions? Any problems so far? Are you understanding what it is that I have there? Anybody need any clarification? Remember, it's the first time I'm looking at one of these, so I'm expecting a lot of questions. So shoot. All right, good. It seems as if I was very clear with the explanation. Are you finished going through and ready for the question, or you need some more time?
Sir, one more thing.
Go ahead.
Why did you square the y?
Why I squared the y? Because I recognize I have a 2 to the 2x, and I know I'm going to end up with a quadratic. So whenever you get a question of this nature, you're going to end up with a quadratic equation. And you know a quadratic equation has a square term, a term in y, and a constant term. So I'm expecting, I know I'm going to get a square term. So in order for me to make a substitution for 2 to the 2x, when I square this, I'm going to get 2 to the 2x. Remember, when you square this, you're not going to get 4x squared. You're not getting 4x squared. When you square 2 to the x, when you square an exponent, you are going to only multiply the powers. So 2 to the x, all squares, is going to be 2 to the x times 2, which is 2 to the 2x. So I need to make a substitution. This question has to be done making only full substitutions. Right? So I'm making a substitution, and having made a substitution for 2 to the x, I recognize that I'm going to be needing one more, and that one is going to be 2 to the 2x.
Okay, sir.
No problem.
Thank you.
You're welcome. 10. Shantae.
Yes, sir.
Oh, you stay.
Good, sir. No question.
Okay. Jenny.
Sir,
Oh, you...
good, sir. No question.
Great. And Javier.
Sir, Javier, and I am good.
Javier, and you're good. Okay, thank you, Javier.
Sir.
Yes, please.
Sir, like we have the 1 and -4. You're going to always use the positive number?
Take again 1 and -4. No. That's not how we do it. 1 and -4 are the factors, and I need to manipulate those factors so I can get the middle term.
Yeah, but sir, in the previous say cannot take the logarithm of a negative number.
Oh, so this is not where we are then. Okay, so I thought this is where we were. So you're over this side. Let's go over this side, right? So what I'm saying to you is that yes, you cannot take the logarithm of a negative number. The logarithm of a negative number does not exist. So anytime you get something like this, 2 to the x equals -4, which is really an exponential equation. So these questions contain the exponential equation, which is why I have the exponential equation from up here. So when I put this here, 2 to the x equals 4, when I say x log 2 is equals to log of -4, when you put log of -4 in the calculator, it says math error because it's undefined. So once you have a negative number over this side here, can't work. So don't want to put -2 squares. That will make it. You can't take the logarithm of a negative number. On the other hand, though, Amelie, you can go ahead and solve 2 to the x equals 1 because it's a positive number. So you can only take the logarithm of positive numbers. Only take the logarithm of positive numbers. Always remember that. Please. All right.
Yes, sir.
Good job. Kamisha? Matthew?
Yes, sir.
Oh, you stay.
All right, sir.
Okay. Manisha?
I'm good, sir.
Nice. Yes, please.
Sir, I'm still not get it. But I just log on to class because my laptop never did allow me.
Okay, you just log on.
Yes.
Okay, that's why. Never mind. We'll go through that. I was actually going to call upon you now because after Manisha is you. Natty D. Oh, you stay.
Sir.
Mm.
I'm okay.
Very nice. Nathaniel? Did I call upon you earlier? No? Oh, you stay, Nathaniel?
I'm okay.
Good. And Chanel?
Yes, sir. I'm fine also.
Good. And I know Tanya is all right. Oi, no, so this a Mullins person at the first class. Me see that person. Me never see. Um, Can you unmute for me, please? Is it Tanuja?
Yes,
Is
sir.
that
Tanuja.
are you first class don't?
Yes, sir.
I'm finished with one. Are you year one or year two, Tanuja?
Year 1.
Okay. STEM or liberal arts?
STEM.
Okay, all right, then cool. Tatiana D. How you say?
Sir, I am okay.
Okay, cool. Tatiana Green, how you say?
Sir, good.
Nice. And Terry, how you say?
Oh, okay.
So hold on there. I put me at work. Somebody asked me one question. Somebody
Sir,
asked
I
me
don't understand. You can go back over it, please.
Natalie, leave me alone, Natalie. Natalie, leave me alone. Leave me alone, Natalie. I'm gonna go back for you today. But you know, you just come on, that's why you don't get it. But everybody may ask them, say them, all right, cool. So I soon gonna be. I don't want to go through it in this view, not to be because it's just too fine. So I asked the students to zoom in because I wanted them to review. All right. So so all of you have reviewed this already? Yes or no?
Yes, sir.
All right,
Yes, sir.
all right, good. So let me close this view so I can look at it. So Natty B can see what is happening. All right. So what I have done, as you know, as per usual, I introduce a topic. I go through I go through a question, and what I do is to be as detailed as I possibly can with the solution, and then I'm going to give you one or two to practice on your own. Well, several to practice on your own. I have started working the solutions for somewhat. Oh goodness.
Sure.
Yes, Papa.
I'll show an example, the complex one them.
The complex.
One of them pass a mark, it says a tricky question.
Oh, so let me ask a question. So when you do the tricky question, Matthew, what you do?
Just means where you do.
Negative. All right, come on, I will do one of them. So, yeah, tricky. All right, so I will do number 1 and then you do number 2. All right. All right, so let us go through for Natty B's sake and for those of you who.
Sir, it's Natalia.
What is the last name?
Okay, I am
Okay, good.
Natalie.
What? Listen.
I never Natalie him say Natty.
Oh, my thing is Natalie.
I said Natty B. You see, and our computer alone want the charger to move. All right. It's not here. All right, so let's go again. So what it is that we're doing is to explain what it is that we started off with. So we're looking at some exponential equations. As I said before, they did ask on your syllabus, one of the very first things is to look at the exponential equations. And we have done the exponential equations of this form, solving exponential equations of this form, 2 to the x equals 1. And then I thought to myself that, you know what? They can give an extension of the thing because these are also exponential equations. And they can give you something like this in the exam. And I don't want them to give you and you don't know what to do. It is best for me to do it and you don't get any of those than not to do it and it come up in the exam for 8 marks, between 5 and 8 marks or 5 and 10 marks. And those are plenty enough marks. So let us go through. So this is what it is. This is a question. The question is 2 raised to the 2x power plus 3 times 2 raised to the x power minus 4 is equal to 0. And then I'm saying that we will immediately recognize that 2 to the 2x plus 3 times 2 to the x cannot be combined to give a single expression. And my question to you is why, sir? It is so because all the laws that we have done spoke about a to the m multiplied by a to the n, or a to the m divided by a to the n. It never spoke about anything with addition and subtraction. So therefore, we can't use any of those laws that has a separator as an addition sign, nor a subtraction sign. Can only be done when it is that you have a division sign or a multiplication sign. Always remember that. So I can't find a single expression to combine this with. So therefore, we need to make a substitution for 2 to the x. Why 2 to the x, sir? Because we're going to use the smaller of the two indices. The smaller of the two indices. So I'm going to let y be equal to 2 to the x, because you will agree with me of the two indices here, that 2 to the x is the smaller of the two. Sir, how you know that? The bases are the same. One power is 2 times the other power. So that means that this one's smaller than this one. All right? And then if y is going to be equal to 2 to the x, when we square y, we're going to get y all squares is equal to 2 to the x all squares. And when we do that, y squares is also going to become y squares, and 2 to the x all squares is going to be equal to 2 to the 2x. Going to be 2 to the 2x, which is this, 2 to the 2x. Sir, how you got that? Remember the law? The law says a to the m raised to the nth power is equal to a to the mn. All right? Now, so therefore, we have a substitution for 2 to the x and 2 to the 2x. We've now generated a substitution for both, for 2 to the x and for 2 to the 2x. I'm recording the equation. So anywhere I see 2 to the 2x, I'm going to put y squared. And anywhere I see 2 to the x, I'm going to put y. 2 to the 2x, y squared, see it here so. That 3 here so, other 3 here so. And the 2 to the x from up here so equal y, see it right here so. The minus 4, hit this. The 0 here so, I hit that. So I now have my quadratic equation. You know, I have a quadratic equation in y. Normally, you're accustomed to getting a quadratic equation in x. Now I have a quadratic equation in y. I need to factorize. So I'm factorizing this quadratic equation. The rule says I multiply the coefficient of x squared by the constant. Lord Jesus, sir. Coefficient, what that mean again? Simply the number in front of y squared. You may say a while ago, coefficient of x squared. This is because I'm accustomed to x. We are multiplying the coefficient of y squared by the constant. The coefficient of y squared is the number in front of y squared. The coefficient of y squared is the number in front of y squared, which is a 1. So 1 times negative 4 is going to be negative 4. I need two numbers. When multiplied together will give me negative 4, but when added will give me a positive 3. And those two numbers are 4 and negative 1. Those two numbers are 4 and negative 1. So how you know that? When I multiply positive 4 by negative 1, I get negative 4. Check. When I add positive 4 to negative 1, I get positive 3. Check. So I know I'm right.
Sir, can you repeat that again, please?
I need two numbers. When multiplied together will give me a negative 4. This one times this negative 4 is equal to negative 4. Hold on.
Sir, I do not know why, but no knowledge.
Listen to me. Don't play me tonight here, because all the other nights things are loud, so I don't know why not lodge tonight. What happened to you?
Sir, I don't know what. Sir, like, me I see the number them, but me not, like, me honestly not understand.
All right, don't worry about it. What I'll do is I'm going to give them all right. Sorry, I'm going to continue because a question just came a while ago. So let me just continue, and then while I give them a question to work, you and I will just go through something. And if there's anybody else that has a difficulty, I'm gonna put you in the breakout room while the other students stay in the other room to do it, and then we can just work out the mathematics. All right, I'm only trying to make this a little. A little bit more self-explanatory. To be honest with me, please. All right. Tell you, were you the one asking me the question, me?
Sir, I was. Oh, you wrote it down. Okay.
So this is what you're asking me about, don't? Tantan.
Yes, sir.
This is what you're asking me about, right?
Yes, sir. Thank you.
Okay, cool. No problem, man. All right, so so let me go again. So we're given the question. The question says 2 to the 2x plus 3 times 2 to the x minus 4 is equal to 0. And we can't go ahead and solve this equation as it is now. Cannot solve this equation as it is. And so we need to immediately recognize that 2 to the x and 2 to the 2x cannot be combined to give you a single expression. So we have to make a substitution. We have to make a substitution. Hands down, without a shadow of a doubt, we have to make a substitution. And when you make the substitution, we are going to replace the 2 to the 2x and the 2 to the x in the original question that was given. In the original question that was given. So therefore, I'm going to let y equals 2 to the x. Sir, why is y equals 2 to the x and not y squared? Y is going to be equals to 2 to the x because we're taking the smaller of the two to set it equals to y. We are taking the smaller of the two and set it equals to y. So y is going to be equals to 2 to the x. Then if y is equals to 2 to the x, in order for me to get a substitution for 2 to the 2x, I have to square y. When I square y, I'm going to get y squared, but 2 to the x is not going to be like you're squaring 2 and you're going to get 4. It is 2 to the x squared, and that gives you 2 to the 2x, sir. How you get that? Recall. Recall. A to the m times a to the n is equal to a to the mn. A to the m times a to the n, raised to the nth power rather, is going to be equal to a to the mn. So when you have a base raised to a power, which in turn is raised to another power, you're going to be multiplying the powers or the indices or the exponents. All right? So that's what happens. So a to the m raised to the nth power is going to be equal to a to the mn every single time, barring none. All right? So therefore, I'm going to have my y squared to be equal to 2 to the 2x. My y squared is going to be equal to 2 to the 2x. Now we're going to substitute. Watch me. I'm recalling what the equation, the given question was. I'm recalling the given question. Having recalled the given question, anywhere in the question I see 2 to the 2x, I'm going to put y squared. Sir, why? See it right there, sir? I think I should put that in red. I think I should put this in red so it pops out. Right? So y is equal to 2 to the x, and y squared is equal to 2 to the 2x. So when I see 2 to the 2x, I'm going to put y squared. And when I say 2 to the x, I'm going to put y. So this now becomes y squared plus 3 times y minus 4 equals 0. So now I have my quadratic equation. Now I have my quadratic equation. And then telling him, sir, remember how to do them something again, sir. And that's why I did the narrative right here. So we're going to multiply the coefficient, which is the number in front of y squared, by the constant. By the constant. And the constant is the one that stands alone. The constant is the one that stands alone.
Sorry, Natalia, sir, Wi-Fi gets gone and she cannot log on again.
Oh dear. So multiply the coefficient. Multiply the coefficient which is a number in front of, coefficient means number in front of, y by the constant, and the constant is the one that stands alone. In this case, it's going to be -4. So that is, I'm going to multiply 1 by -4 to give me -4. Now we need two numbers. When multiplied together gives -4. But when added, gives +3. Oh, the +3 in the middle, sir. It's same one. It's same one. It's same one. Gives +3. All right. So the factors. So the factors are 4, +4, and -1. So the factors are +4 and -1. All right. Factors are +4 and -1. So what I'm going to be doing now, I'm going to now substitute, meaning say, me I break up this +3y into 4y minus y. Why 4y minus y again, sir? 4y minus 1y. Same difference. All right. Now, I'm going to be grouping because I'm factorizing by grouping using a grouping method. I'm going to be grouping. So I'm going to put the first two in one bracket, leave the middle sign out every time, and then put the other two in the other bracket. Whenever you factor out a negative sign, always flip the sign after. Always flip the sign that comes after. All right. So I'm factoring out a negative sign. See it here? I'm flipping this sign. So it was negative up here. It now then becomes positive. Besides, whatsoever sign that is in this bracket here has to be the same sign in this here bracket. Whatsoever sign in this bracket has to be the same sign in the other bracket. All right? And then I'm factoring. So I'm asking myself the question, what is common here that is common there? What is common here that is common there? What is common is going to be y. So I'm factoring out the y. What is left is going to be y plus 4. What is left is going to be y plus 4. Y plus 4, that is left. And then I'm asking myself the question, what is common here that is common there? And your answer is going to be -1. And when I do -1, I'm going to have, hold on a minute, please. Hold on a minute. Sorry about that. So whenever you factor out a negative sign, like right here, put it this way. This will always happen. Every time you have a negative sign separating the two parentheses, just remember to flip the last sign. And that's why I put it in pink. Always remember to flip this last sign. Besides, whatsoever sign that is in this bracket has to be the same sign in this bracket. The same sign in this bracket has to be the same sign in this bracket. All right? Then I'm going to factorize. What is common here that is common there is going to be y. What is left is going to be y. And positive 4 will be left here. And what is common here that is common there is 1. What is left is going to be y plus 4. Again, whatsoever is in this bracket has to be the same thing in this bracket. And my question to you now is, what is common here that is common here? The same thing in the bracket, sir. Very good. My y plus 4. So I'm factoring it out. What is left is going to be my y minus 1. What is left is going to be my y minus 1. So that constitutes my two sets of values. So either y plus 4 is equal to 0, or I'm going to have y minus 1 to be equal to 0. Y plus 4 is equal to 0, or y minus 1 to be equal to 0. And then, if y plus 4 is equal to 0, it means that y is going to be equal to negative 4. I've shown you how I did it right here. Y is going to be equal to negative 4. And if y minus 1 is equal to 0, it implies that y is going to be equal to positive 1. And I'll show you these steps that you can look at to arrive at your positive 1. Now, remember the question never gave us anything in y. We were the ones to introduce y. We were the ones to introduce y. The question never gave us anything in y. We introduced y. So what is going to happen is that we have to resubstitute. So either y to be equals to negative 4 or y equals to positive 1. That's what we calculated. Recall that we were the ones to introduce y into the question. Therefore, we need to remove it. We cannot leave it in like that. We were not given it. We were not given it. So recall that y is equal to 2 to the x. So why not using y squared? I'm not using y squared because I don't have a y squared value here. I only have y. So that's why I'm not using this y squared value, this one. And I'm only using this one because my answer, as I calculated, got only y equals negative 4, not y squared equals negative 4. So if anybody's thinking of that question, that's the answer. Let me answer it before you ask me. And then what it is that we're going to have is to make the substitution. So y is equal to 2 to the x, but y is equal to negative 4 in one instance, and y is equal to negative 1 in another instance, and y is equal to negative 1 in another instance. All right, so it's equal to negative 4 in one instant and positive 1 in another. So we're making a substitution. We're now making a substitution. We're now making a substitution. What's the substitution, sir? See here. This y is going to be negative 4. So it's going to be negative 4 is equal to 2 to the x. Negative 4 is equal to 2 to the x. It doesn't matter how I write it. It's the same thing. It doesn't matter how I write it. It's the same thing. Doesn't matter how I write it, same thing. Doesn't matter how I write it, same difference. All right. So when I have this y to be equals to 2 to the x, I'm going to have negative 4 is equal to 2 to the x. Or I'm going to have positive 1 is equal to 2 to the x. Same matter of fact, I'm not going to change that one because it's the same thing. It's an equation, and my equality says that I can write it anyway. Read it from the left or the right gives me the same value. So there are no real values for x that satisfy 2 to the x equals 4, which is this one. No real values that satisfy that. What does this mean? You cannot take the logarithm of a negative number. You cannot take the logarithm of a negative number. So therefore, we have no solution for that value of x. We have no solution for that value of x. So what we have now is 2 to the x equals 1. I have 2 to the x equals 1. And 2 to the x equals 1. I'm not going to do this because we've done that before. All of last class, that's what we did. What I'm going to ask you to do for me is to try writing this question down and try that one for me. Try that one for me. I'll give you a couple of minutes and then I'll come back to you. Give me a minute, please. How is it going, guys? Are we understanding? Do you want me to, for you to write out the question and then for me to project this, the workout so you can have a look at that?
Yes, sir.
All right, so let me know when you've written out the question. Question 1. Write off question 1 for me. And then let me just project the workout so you can zoom in and look at it and follow the steps.
Okay, sir.
All right, everybody has it?
Yes, sir.
Yes, sir.
Yes, sir.
All right, there you go. And incidentally, I remember about the test here, so don't think I'm having a brain freeze. I remember.
Sir, but we can't do it.
Why?
Because we have a new student that would have been unfair.
Why are you so concerned about the new student?
Sir,
Someday later she gonna need a grade to sir. You can't be inconsiderate.
sir, remember say bad no day, you know.
Oh, really?
Now work and some of them laptop I lag them out and then something this.
And there's something there, but Miss Campbell, you're very concerned. You're very concerned tonight. All right, go on work the question. Guys, on a two silent, I'm sitting here and I'm saying, but where am I? Am I in class or am I somewhere else? How are we going? Are we finished? Are we understanding? What is it? Talk to me.
Sir, send something up.
You did something?
I send the answer
In the chat. Okay. All right, hold on. I'm here looking at the computer.
Sir,
Please.
sir,
I'm hearing you. Go ahead.
sir, where did I say about the sign, the sign, the negative sign again?
What do you mean?
Yeah, did I say the reason why the positive sign is instead of the negative?
Oh, whenever we factor out a negative sign, the other sign is going to flip. You get that?
Sir, so in this case, when you factor out the whatever, if one positive number there in the bracket, it will go flip to negative, and if one negative there in the bracket, it will go flip to positive.
Yes, that's it.
Okay.
Only when you have a negative sign in the middle. You see what I'm saying? When you have a positive sign, it's not now gonna happen. Only when you have a negative sign. All right.
Sir, really?
Absolutely.
Jeez.
I said that. I said it though. Like seriously, I did say it. All right, look back at yours. I'm gonna. Oh Lord, did I do number one? Jeez, I look, I'm sitting here. Let me look at numero uno. All right, this thing's moving so slowly, my goodness. See the notation here? Once the middle sign is negative, then flip the sign. If positive, left it alone. Give me half a second, please.
sir.
All right. So I have projected what it is that I have here. Are you in agreement with my workout right here? Any disagreements?
Sir, I agree.
Okay, good. Is there anyone else who would want to agree with me or disagree with me?
Agree, sir.
Good job.
I agree.
All right, and then now we go all the way down, and you got x to be equals to -1 and x equals +1.
Yes, sir.
Is there anybody in the class that was struggling with that one? Didn't get that one? Let me know. Speak up.
Sir, so where is it to the first bowl?
Raise it to the first four because go ahead.
Because I did just divide it and get 0.5.
Oh, okay, but you still get the same answer. So x is equals to -1, x equals -2. All right, so that looks good. That looks good. Yeah, but I mean, same difference. The same 0.5 is 1/2. But don't use that 0.5. Always try to use it as a fraction instead of as a decimal. Here?
Yes, sir.
Nice. Okay, very good. Now, I did not do question number 2. I, however, did question number 3. All right. So because question number 2, I don't want to do question number 2. All right. Do question number 5 for me, please. Do question number 5. I have not done it, so I'm going to do it while you're muted. Question number 5. Let me just position it here. That's 6. You position 5 right here. Question number 5. Can you write it down for me, please? And then go ahead and start working for me, please. Now remember, the more you work these questions, the better you get at them. All right. So try working 5 for me, please. Wanna good? Or is it going? All right.
Yes, sir.
All right, guys. So where are you going? Hello, somebody.
Good, sir.
Honesty.
Okay, sir.
Look at my screen and see if you agree with me. Or it's still working, you don't reach as far.
Yes, sir, that I get.
Good. You notice what I did here. I deliberately changed the substitution from Y to U because I don't want anybody in the class that is only Y we can use. We can use any value to substitute. We can use any value to substitute. So again, I don't want anybody to think that that is only Y alone we can use. So what I did was just to go ahead and use U as my unknown this time. What's the main thing to know, or what are the topics that you need to know in order to do a question such as this? What are the skills that you must have in order to do this topic? Somebody talk to me, please.
Substitution and factorization.
Factorization. What other two topics? Two other skills. Factorization is one. Go. Huh?
Substitution.
Well, factorization. No, not substitution. So factorization.
Indices.
Indices. And one more.
Transposition.
No, that will come in the whole stuff. What about logarithms? Do you think we need to know logarithms in order to do this question?
Yes, sir.
Right. So the prerequisite skill would be Factorize. So factorization, either by grouping, whatever it is, logarithms, Logarith, and indices. So we need those three prerequisite skills in order to do that topic. We need to know our factorization. We need to know our logarithms. We need to know our indices. Because sometimes you recognize that the first question you did with the one that you're able to use indices just to do that one, don't it? Bases are the same, so you equate the powers, don't? Talk to me, somebody.
Yes, sir.
Right,
Yes,
but in this case, could I use indices for number 5, the one that I just did?
No,
no,
sir.
sir.
No, we had to use logarithms. We had to use logarithms because I couldn't write the left-hand side in the same base as the right-hand side. But in the other one before, I could do that. In question 1, look at what I have. I had 2 to the x equals 2. So I could go ahead and just write the left-hand side equals to the right-hand side and go ahead and just get my question quickly. So some of the questions you don't have to use logarithms, depending if, and the only time you don't use logarithms, as I told you, the only time you don't use logarithms is unless you are able to write the left-hand side in the same base as the right-hand side. But if you can't write both sides in the same base, then you end up now have to use logarithms. You remember that conversation from last class?
Yes, sir.
Right. That's the conversation. So those are the prerequisite skills, and those are things that you need to know in order to get those questions out of the way. All right. It's 8 minutes past. Let's just do one more, and then we'll call it an evening. I'm not giving any test today. When I said to you, let us play it by ear, and people asking what I mean by that, you know, I reserved from having a conversation, you know, as to what transpired on campus. I regret it. All of us regret it. I think something is going to come out to all you students. It's unfortunate. I have been at the college teaching for many years. This is a first situation like this that has happened. and I'm really very saddened by it. So, you know, I am here apologizing to you. And I saw the comments that, you know, people wanted to go pay exam fees and rate take, and they were supposed to go back and they not go back there today. And, you know, I really apologize. In any event, the college is closed for today and should reopen on Monday. So I apologize for the inconvenience. I apologize for this, for all of those stuff. But I will assure you that the campus is very safe. The campus continues to be a safe place. I've been there working for more than 2 decades, and you know, I can tell you, I feel safe when I come there, and that's why I'm there so long. I feel very safe. So don't listen to what the media is saying and trying to portray. It's just an unfortunate situation, really, really, really unfortunate. And again, I apologize. So let us see if we can. So when I said to you, let us play it by ear, based on the comments coming from the class, I say, you know what? Let me put it off. So I'm putting it off for Monday. Putting it off for Monday. All right. All right. So, and I'm also very aware that we have 17 of us here, and it's only a few students that have responded to me, and I'm here in the comments. So I know the rest of you are either asleep or watching something. Don't know what comes on at this hour, but watching something. Guys, come on, let's go. All right, let us look at one of the tricky ones. And let me just explain the tricky one. This one I said is tricky. This one I said is tricky. And why am I saying this one is tricky? 3 to the 2x plus 1. How do you think we can do 3 to the 2x plus 1? Let me see, did I do number 2? All right, so let me just start off this. Let me start it off for you. Three to the 2x plus 1, we're going to let y be equal to 3 to the x. We're letting y be equal to 3 to the x. When we square y equals 3 to the x, we're going to get y squared is equals to 3 to the 2x. We're going to get y equals 3 to the 2x. All right? So therefore, look at what I'm doing. And I'm stopping right there, and then you can do the rest. I am breaking up 3 to the 2x plus 1 into 3 to the 2x times 3 to the first power. Look at that and tell me if you see and agree with that. 3 to the 2x plus 1, I'm breaking up as 3 to the 2x times 3 to the first power. Look at it and tell me if you agree with me.
Sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, one question. When we do them problems, I always try to get the first part, the first part equal to the second part. I get to me, I say. Which part of y squared would that be? You always try to get it to equal to the next power.
No, not the y squared, not the y squared. What I'm trying to do, I don't know if I'm following you. You're talking about this compared to this?
You have the 3x. First, when you look on it, you say y equal 3x and 3 raised to the power x.
Right, 3 raised to the power x, yeah.
Yes, somebody asked when we get them problems of always use set y as that part of the equation, eh?
As this term, the smaller of the two terms, yes.
And when we do that, when we do that now, we try and make the other power, the other side, we put highlight in a purple or whatever color that. If I try to get that part that's equal to
y squared.
Yeah.
Yeah. Because we're going to end up with a quadratic equation. So yes. So Matthew has seen a particular trend in something there. So look at what is happening here. 3 to the x, 3 to the 2x plus 1. 3 to the 2x plus 1 is the same thing as 3 to the 2x times 3 to the first power. 3 to the 2x times 3 to the first power. Take it from there for me, please. No man, on the silence, on the silence, on the silence, on the silence, on the silence.
Sir,
Mm-hmm.
sir, you can remind me about the thing that you said about when there's a factor, when you factor out a negative sign, it always flip it.
Once the middle sign is negative, like up here so, then flip the sign, this sign. So this is a positive sign, that is going to be negative. Tell me if it's what I just showed you. Hello?
Sir, I'm reading it.
Okay.
Okay, sir.
Good job.
Sir, can I go back on the question, please?
Sorry, I apologize. I apologize. It's too late to apologize. Oh, which one I'm doing? Which question are we doing? Question 2? Or, oh Lord. Oh, that question. Yes, some of you that are still not talking to me. And that's why I want to do this.
Sir.
Yes, please.
Sir,
Go ahead, Matthew.
check the chat. I send you,
Oh, sorry. Yeah, man. Thank you, sir. Okay, all right. So I wasn't checking the chat, so I'm seeing some. All right. All right. So Shan and Shani. No. Christiana and yeah, and Shani. Half right. Very good, Matthew. You know why it's half right for you too? You only give me x equals 2. You have to tell me say there's no solution for the other one.
Yeah, we didn't know that.
Yeah, man. I'm going to tell you why. I'm going to tell you why. You have
Sir, that's what I got.
Very good. You have a quadratic equation. When you normally have a quadratic equation, how many answers you get?
2.
Very good. 2.
Sir, but it implies that we send you one answer.
Exactly, sir.
It not implying nothing. I want to see that there's no solution. No, man. So you remember, when you get a quadratic equation, you're getting 2 answers. You normally have 2 answers to the quadratic. So when you give me just one answer, it doesn't imply you could leave off something else. So let me know that there is no solution for the other one, and that the other one is x equal to. Just as Holster write it, no solution for that one, and x equals 2 for the other. Yeah, so you notice it didn't use indices, logarithms for this one again, because you could write both left-hand side and right-hand side as the same base. So we use indices to solve. So the prerequisite skills here are factorization. You must learn and know how to factorize. There is going to be something that speaks about application of differentiation when we move into calculus. That's module 3. And again, in module 3, we are going to buff up factorization one more time. We're bucking up not module 3, I'm sorry. Yeah, I'm right, module 3. We're bucking up factorization again. So you have to be able to master the factorization to a point where you should be able to factorize by inspection, meaning that you're going to just look at the question and factorize it. Look at the question and factorize it. All right. Let me tell you what I observed tonight. I observed just a handful of students that turned up for class. Sir, we have 17 students and you make 18 serve. I'm not talking about the physical bodies that are here. I'm talking about the ones that participate in class and the ones that I believe, the ones that have demonstrated to me that they have learned. It's just a handful. The rest of you were visitors to my class, and I don't want visitors to my class. I want persons who are going to come and till the soil. Now, ask those students who are understanding how it is that they understand. And I can tell you without even asking them, by practicing, and more practice. Students, you have to become actively engaged in your classes. You have to become engaged actively in your math class. I'm going to say it on the record again. I am not pleased with the level of nonchalance that comes to the class. Some of you don't, if I don't call on you, you don't unmute to talk. Well, the good thing about it is that when I call on you, you unmute. But I want to hear from you. I want to hear that you're understanding and that you're learning. Remember, online is what we have, you know. I have to make very good use of whatever we have. In life, whatever we have to make very good use of it. So I'm going to ask that you make the best use of this, your online experience. So it is that together we can, you know, walk, talk, and sing mathematics. All right. Are there any closing thoughts, any questions? Anybody wants to let me know if you learned anything tonight, you know, just to sum up? Ablame, talk to me.
Sir, we learn of something.
You learned of something.
Finally understand factorization.
Well, guess what? I'm happy for that. I'm really happy for that. And I'm coming to you, so I hear somebody trying to get in. Tell me how it is that you understand the factorization. What made you understand the factorization?
Yeah, because they showed me the part where you said about the multiply the coefficient one.
Very good, very good. And that's why I did the narrative. Because when I put the narrative there and you see it, it makes life very, very easy. Somebody's just coming in. Very good, Shanshan. Somebody's just coming in. Who was that?
Oh yes, sir. I was saying that if you say like one of them do have no solution, like if getting an exam paper after write that.
Yes, please. Yes, please. But one of the things though, one of the things that I believe that CXC will do is to give the question where it is that you have both solutions. I don't think, like in some of the examples that I have here, some of them have no solution for both. CXC will not give you that. I only gave you because I wanted you to get the practice. But CXC will not give you a question where you have no solution. So I quite frankly believe that you will get a question, if this question comes, where it is that you have both solutions. Because it's quadratic, they are going to give you both solutions. All right? But I want you to write it so it is that you recognize that you're supposed to get two sets of values for your answer. All right? So that's very important. In the final thoughts, I mean, I enjoyed my class. I had an opportunity to not to be miss out, but she will be able to watch the recording. Guys, you see all of them something here with them color codes and them thing there. It requires a lot of preparation for me to sit and prepare these notes for you and to highlight the areas that I believe are very important to be highlighted. I don't want to make my notes gather dust. Use my notes, use them wisely, try and digest them. Digest them in bite-sized chunks. By the time you finish, you have the information, guys. You can reproduce the information whenever it's necessary. All right? So you've done well. Thank you. Thank you for coming out. See you on Monday. Prepare for the test for Monday for me, please. Huh? All right, good night.
Bye, sir.
Bye-bye.
Sir.
Bye, sir.
Bye, sir.
Bye-bye, dearest.
Sir, can you send this in the group, please?
Always.
Get the chat card, people talking in the chat card, some people not like it.
Yeah, man, I check the chat, man. I saw the chat.
Alright.
Aha, we shy. Which part of you shy? Come off of the phone.
Sir,
Yes, please.
is there a case where both answers are positive?
Say it again.
Is there a case where both answers are positive?
You have all possible cases. Yeah, you can have that case too.
Okay.
So when you have that case and both answers are positive, you end up with no solution for both downs.
I guess.
Yeah, man. Right. Yeah, that's what I was referring to. Yes, please.
Sir, oh, we get the test.
Is that? I'll talk to you about that. We can devise a plan. Don't worry about it, man. Just prepare. I just want you to prepare. Prepare and make the teacher proud. No.
Oh, we get it.
What you getting on the test, you said, or where?
No, not what we getting. We know so we get everything.
Like,
oh, we get it. Like, if we go depend Zoom or it's go pan test, whatever.
It's going to depend Zoom, man. We're going to depend Zoom.
Oh, okay, sir. Yeah, so we're going to take the picture and send in there.
Same way, someone. But we're going to show it. That's why I said, don't worry about it. I'm going to show the class over the week.
Okay, sir.
Yeah, man. Bless your heart.
Bye, sir.
Bye-bye, honey bunches.